Question 1 is graph transformations, and in part A we've got to do y is f of minus x and then add 1. Well, f of minus x is a reflection in the y-axis, so the graph is going to end up looking like this. And then we've got to add 1 to it, so the final graph is that graph there, but 1 added to it. So this point here, 2, 3, became minus 2, 3, now it's at minus 2, 4, because 1 is added to it. And this point here was at 1, so that's at 1, so now that point there is at 2. It does say show the coordinates, so we should write it as a coordinate. So that's part A. Part B asks for f of x plus 2 plus 3. So f of x plus 2 translates the graph 2 units to the left, because it's the opposite of what you think. So this 2, 3, which was here, now becomes 0, 3. And then if you add 6 to it, that point there is at 0, 6. And it should be clear that this is the maximum point of the graph. And in part C, we've got 2f of 2x. So firstly, let's do f of 2x, that squashes it all together. So instead of being at 2, 3, it's at 1, 3. But then the whole graph is stretched by a scale factor of 2 in the y direction. So this point here becomes 1, 6. And then this point here, which was at 0, 1, that has now been stretched scale factor 2, so now it's 0, 2. So now in question 2, we've got to write this in the form r sine theta minus alpha. So think of a magic number. The magic number is 2 squared plus 4 squared. So r squared is 2 squared plus minus 4 squared. That works out to be 20. So r is the square root of 20, which is 2 root 5. So we can think about sine theta minus alpha. That's sine theta cos alpha minus cos theta sine alpha. So therefore we get 2 sine theta minus 4 cos theta is 2 root 5. Then we've got sine theta, and then it's 2 over 2 root 5 minus cos theta, and it's 4 over 2 root 5. So now we can directly compare cos alpha with 2 over 2 root 5. So cos alpha is 2 over 2 root 5, that's obviously 1 over root 5. So therefore alpha works out to be 1.107. So finally let's write it in the correct form. So it's 2 root 5 sine theta minus 1.107. Now in part B we've got h of theta equals this expression here. So it's 4 plus 5 lots of, and then 2 sine 3 theta minus 4 sine 3 theta. That's more or less what we had before. So it was 2 root 5 sine, but now it's not theta, it's 3 theta. So I need to write 3 theta in here. Minus 1.107, and there's a squared. So we can write it like that. Now the maximum value of h theta obviously occurs when this whole expression is at a maximum, and the maximum value of sine of anything is 1. So all of that part there is 1. So the maximum value is 4 plus 5 lots of 2 root 5 times 1 squared. So that's 4 plus 5 times 2 squared is 4, root 5 squared is 5, so it's 4 plus the 100, which is 104. So the smallest value for which this occurs when sine of 3 theta minus 1.107 equals 1. So therefore 3 theta minus 1.107 equals pi by 2. so therefore theta works out to be 0.89. Don't forget that that's a 3 theta here, so when you're solving this equation you have to divide by 3 at the end. Now in part C we've got to find the minimum value. Well, the minimum value occurs when this bracket is at a minimum. There's a squared bit here, so any real number when you square it is going to be positive, or the minimum value is going to be 0. So this whole expression will have a minimum value when when sine 3 theta minus 1.107 is 0. So the minimum value is 4 plus 5 times 0, which is 4. This is squared. Don't start thinking that this could be the whole expression could be minus 1, because when you square it we can't get minus 1. So this occurs when sine of 3 theta minus 1.107 equals 0, and that equals 0 when 3 theta minus 1.107 equals 0 or 2 pi, etc. So 3 theta is 0 plus 1.107, or 2 pi plus 1.107. So etc. So theta is 1.107 divided by 3, or 2 pi plus 1.107 divided by 3. So that's 0.369, or 7.390. Remember, it's 3 theta, not theta. So now divide by 3, we get 0.123, or we get 7.390 divided by 3, which is 2.46. Now it asks for the largest value between 0 and pi. The next one after this, if we had 4 pi here, this value here, that will give you bigger than pi, so therefore theta is 2.46. That's the largest value, not the smallest value. In part B it was the smallest value, in part C it's the largest value, and there it is, 2.46. Now question 3 asks you to separate these variables, or asks you to solve the equation. So to do that we separate the variables. So it's d theta over 120 minus theta equals dt, and obviously that's lambda dt there. Now if we differentiate the bottom here, it nearly makes the top. It would do if there was a minus sign there, so let's put a minus sign in like that. We can now integrate, so we get minus ln 120 minus theta equals lambda t plus c. You know that theta is 20 when t equals 0. So that means minus ln 100 equals c. So we get minus ln 120 minus theta equals lambda t minus ln 100. There's a minus sign there. Let's add ln 100 to both sides, and we get a ln minus a ln, so it's ln of 100 over 120 minus theta equals lambda t. Let's do e to both sides, so 100 over 120 minus theta is e to the lambda t. Let's put the 120 minus theta on the right hand side and the e to the lambda t on the left hand side. So I've got this. Put the theta over here, and it's 120 minus 100 over e to the lambda t, and so therefore theta is 120 minus 100 e to the minus lambda t. Proof complete. Question 4, part A, the missing number works out to be 0.73508. And in part B, using the trapezium rule, so it's a half of pi by 8, the first number plus the last number plus 2 times the middle numbers, and that works out to be 1.1504. Now in part C we've got to use integration by substitution. So we've got 2 sine 2x over 1 plus cos x dx, and u is 1 plus cos x. Now if I differentiate cos, it's minus sine. So this becomes, oops, here we go, this becomes 2 sine 2x, well that's 4 sine x cos x, dx is du over minus sine x, so let's put the minus sign out there, and 1 plus cos x is u. Sine x divided by sine x is 1, so it's minus 4. Then I've got cos x at the top. Cos x is obviously u minus 1. So it's minus 4, u over u is 1, 1 over u is 1 over u. So we can now integrate these bits separately. So it's minus 4, and then 1 integrates to u, 1 over u integrates to ln u, plus c. Okay, let's move on to the next slide. Now we need to substitute back in, because we know what u is. U is 1 plus cos x. There we go. So it's minus 4 times 1, that's minus 4, plus 4 cos x. No, not plus 4 cos x, minus 4 cos x. And then we've got minus 4 times minus ln, so that's plus 4 ln 1 plus cos x, plus c. So we've got minus 4 here, we've got plus c there, those two together are combined to make another constant. So we end up with 4 ln 1 plus cos x, minus 4 cos x, and then minus 4 plus c, that's k. Now in part D we have to calculate the error of the estimate in part B. So we need to now evaluate plus 4 ln 1 plus cos x minus 4 cos x. Don't need to bother with the constant because we're evaluating it from 0 to pi by 2, and that works out to be 4 minus 4 ln 2. So the error is 4 minus 4 ln 2 minus the original answer, which was 1.1504. It doesn't say percentage error. If you were to work out the percentage, 6.3%, you'd get the full marks, but the actual error is 0.077. You can write that as plus or minus. Now in question 5, in part A, it says write down the coordinates of A. So because there's only 1 mark, it's not a normal hard intersection of lines question. You can just look at it, you can see that both of the lines go through minus 6, 4, 1, minus 1. In part B, the angle between the lines is the angle between the direction vectors. So we need to do 4 minus 1, 3, dot 3 minus 4, 1. So these are the direction vectors of the lines. So that's 12 plus 4 plus 3, that's 19, that's the easy way. The harder way of doing it is to do the square root of 4 squared plus 1 squared plus 3 squared, and then 3 squared plus 4 squared plus 1 squared cos theta. So root 26 times root 26 is 26, so therefore 26 cos theta equals 19, therefore cos theta equals 19 over 26. The question says find the value of cos theta, not theta. You don't need to work out what theta is, it's just what cos theta is. In part C, Substitute lambda equals 4 into that first equation and we get 10, 0, 11. Again, it's a coordinate, so you should write it as a coordinate. The vector ax, so what do you do to a to turn it into x? Well, think about 10, 0, 11 and take away minus 6, 4, minus 1 and you get 16 minus 4, 12. So that's the vector ax. In part E, the length of that vector is 16 squared plus minus 4 squared plus 12 squared, all square rooted. Because to show that you need to make it clear you're doing that. That works out to be the square root of 416, which is the square root of 16 times 26, which is 4 root 26. Now in part F, it's the last part, there's a sort of geometry type thing. We need to draw a diagram to work out how to do this. We've got two lines that intersect. They intersect at A. A is where they intersect. We know the value of cos theta is that, and y is on L2, and it says the vector y, and x is also on L1, by the way, says x, and then yx is perpendicular to L1, so that means we've got that diagram there, so that right angle. We want to find the length of AY, let's call that D. We know the length of AX, that's 4 root 26. So what we've got is a right angle triangle here. We know that length, that's the adjacent, and what we want is that length, the hypotenuse. Oh, adjacent hypotenuse, cosine. Oh, that's lucky because we worked out cos theta. So cos theta equals AX over AY. In other words, 19 over 26 is 4 root 26 over AY. If you solve that equation, AY works out to be 27.9 to 3 sig figs.